Hello and welcome to day 3 of integration by parts, titled How About a Shortcut. And as the name implies, we are going to come up with a method to quickly do integration by parts. I've put the result from example 4 here and the result from another integration here that we're going to use to inform this new method. Here we have the integral of x cubed e to the x dx, which we did by integration by parts. And we notice x cubed, 3x squared, 6x, and -6 here as being our choice of u, and then in the next term the derivative of that, and then in the next term the derivative of that, and finally the derivative of that. So we have successive derivatives appearing in the integral, or in the in the solution here, the evaluation of the integral. So it looks like there's a bit of a pattern there, and I did this slightly longer integration by parts problem. And I did it using the method of integration by parts, inside of integration by parts, inside of integration by parts. I think there was 4 of them I did all together to come up with this solution. But it shows better the pattern. Here I have u, derivative of u, the derivative of the derivative of u, the derivative of the derivative of the derivative of u, and finally the derivative of that, all showing up as factors in successive terms in the integral. Also, if our choice of, if we call this dv, which we did, then this would be v, or the integral of dv with a 0 constant. This is actually the integral of that, each time with a 0 constant, so I'm just going to put a little asterisk here because we're having 0 constants here. And this would, this actually turns out to be the integral of the integral of the integral of dv, and so on. So the term has successive derivatives of u and integrals of v with alternating signs. So we're going to come up with what's called a tabular notation so that we can quickly write out the integral solution of integration by parts with a particular choice of u and dv. Now here my u was x to the 4th, and dv was e to the 3x. Had I gone through and just generated successive derivatives and successive integrals, e to the 3x over 3, e to the 3x over 9, each with a 0 constant. I'm not adding a constant and then integrating that. And e to the 3x over 243. Had I done that, I could have just used this table to generate this solution, which took quite a while. Again, there's 4 integration by parts inside of each other. That's a lot to keep straight. Using this tabular notation, deciding on u and v, calculating successive derivatives down the column under u, and integrating each time for the new entry in the column under dv, I can combine them to come up with the terms. Now I'm going to alternate signs. And you'll see that I'm getting the correct solution, or the solution that I got before, which is correct. And now I'm going to subtract 24x times e to the 3x over 81, and then I'm going to add 24. I'm alternating the signs here. Not that they'll necessarily alternate in the solution, because we could get negative values for integrals and derivatives. Yeah, 24 e to the 3x over 243, and then plus a constant because it is an integral here. Okay, so the method is put a choice for u at the top of one column, your choice for dv at the top of the other column, calculate successive derivatives in the column under u, and calculate successive integrals with zero constants. I'm not adding c here and generating this family of polynomials tacked on here. I'm just taking that particular antiderivative with zero constant each time. Okay, and then I combine them in this fashion, u with v, remember our formula was uv, and then du with the integral of v, or the second integral, special zero constant integral of dv. And so we come up with these terms just in that fashion, alternating signs, and that's the trick for tabular. This is called tabular integration by parts. I think sometimes it was popularized in India, and so they give it some sort of sometimes refer to it as some other method, but it's called tabular integration. And yeah, you decide on u and v and calculate successive derivatives and integrals. Eventually your derivative is going to be zero, hopefully, and you'll get a zero term, and that's when you're done. So that's the method. You have for homework 1-2 problems. If you wish to continue watching, I will put up another video for example number, well, no, I'm not going to do example number 4 again, but I'll do example number 5 just so you can have complete notes in another video that says integration by parts 3, example 5. But that's the method.